Hi, welcome back to the shop. It's good to see you again. Over the past few months I've had several email conversations with people who have this machine. It's a Syil X4 and I don't do tool reviews. However, this one I've had for so long that I feel that I've had a little bit of experience with it. So I think it's probably worth having a walk round and see what I've done to it, what I thought was good about it, what I think wasn't so good about it, and we'll have a little poke round it. So roll the titles and I'll see you at the other side. So why now? Well, I've just been looking and I didn't realise, but I've actually had this machine now for just over 10 years, between 10 and 11 years we think. Can't find the original receipt, so I'm not really sure. However, your first question is going to be, how much did it cost? And that's a fair question. I paid, like I said, between 10 and 11 years ago, this was, I think it was about the £5,000 mark. And I bought it for two reasons. Firstly, my background is broadcast and I designed an LED light to go on top of a camera, a professional camera, to basically squirt light in people's faces for interviews, that sort of thing. And I got funding through a business startup organisation based in the UK at one of the local universities, and so they gave me a grant. They thought the design was quite good. They gave me a grant to help me get started. That purchased this machine. I bought it with primarily because the light I designed needed to be machined in 4-axis, and this at the time was the only hobby machine I could find, hobby grade machine, to prototype stuff. Was what I needed it for, with a 4th axis, so hence that's why I bought it. It's been very reliable. It's not a bad machine, to be perfectly honest. We'll take a closer look at it and I'll go through some pros and cons. Right, so here it is. I guess the first thing is this was a cheap machine. At the price that I paid for it, I think you can't. This is an obsolete model, and when you look at Syil as a company now, they're far more into their industrial machines. This is clearly based at the hobby, prosumer, prototyping, education sort of markets, which I guess in the scheme of things is probably quite small, hence they're more into their industrial machines these days. The X5, which they do nowadays, is a full machine in a floor standing cabinet with an auto tool changer, a BT30 spindle, and it can do rigid tapping, and it's just a beast. This is a toy by comparison. So this was cheap, and it came with the 4th axis, which is laying under the dwarf in the bottom there. That was extremely useful for me. The other really useful thing is that this can be used in a manual mode. So plugged into the side of it is an MPG, a manual pulse generator, for those people who don't know, but it's basically just a controller. So if I put this into manual mode, take it out of CNC, put it into manual mode, there we go, MPG, you can select on here which axis you want to move and how many steps per division the MPG moves the table by. So if I put it to ×1, it's moving the table at one position, one pulse for every movement, every single pulse on here. So that's the minimum the maximum resolution it'll move by. And then you've got ×10, which is pretty, that's almost one. That feels almost 1-to-1. And the most dangerous one is 100-to-1, because you can easily, and I'll show you what I mean, you can easily crash it into the end stops. There we go, I hit the end stops. That is, I think, one of the limitations of this machine. In manual mode, it has limit switches, but they only work under CNC control, which strikes me as being slightly bonkers, because this pulse generator plugs into the CNC breakout board in the back of the machine. So why you would not have the limit switches activate this and cause it to stop is beyond me. But I guess that's a price limitation. So that brings me on to another thing that I think is not too cracky with it, in that because you can crash it relatively easily, you can the stepper motor for the y-axis is under the back. It's actually at the bottom of the casting, which means if you break the Oldham coupling, I think it's an Oldham coupling in these that goes between the CNC and the ball screw. If you break it, and a few people have managed to do that because I've seen it on the forums, you have to take the damn thing to pieces to get at it. Whereas if the motor was on the front here, it would be a piece of cake of drop the motor off, put a new coupling on, put the motor back. So much simpler. And I think in later iterations of this, they actually did move the motor to the front. This one has got it in the back there, which isn't too cracky. Another few things while I'm having a whinge. These way covers are utterly useless. The concertina way covers. The problem is they just fill up with chips and they jam. And I've never had it to the point where it is stopped the table, but you can hear it's really squashing the chips when it gets full. So if you're running a cycle for a long length of time, you get lots of chips. Those chips don't clear out of these concertinas and they block them up. That's a bit of a pain in the butt, because ideally, you know, for a CNC, what you really want to be able to do is just get it going and bugger off and do something else. You know, go and put a kettle on. So that's an issue. The one at the back here that covered the vertical Z-axis literally fell to pieces. So that's why on my machine you won't see one, because it's utterly crap. So I disposed of it. And also, I don't know if you can see that particularly well. I'll give you a close-up, but the head is supported with a hydraulic spring. No, an air spring. What do you call them? Gas spring. Supported by, that's the word, a gas spring. And this one has failed. And again, I think that's quite a common problem. And it's failed because it's upside down. These things, I believe, are supposed to be installed so that the oil that's in them runs to the moving seal. The moving seal's at the top on this one, so there's no oil on it. So it was engineered to fail. That's not good. Right, so moving on. The manual mode on this is extremely useful. Like I've said, if you want to machine something, you can do it manually, which means that you can use this machine just like an old-fashioned mill. It's just you have to crank this handle instead of cranking the way handles. So it is very useful, and because it's got a display, you can effectively, you've also got a digital readout on the display, so you can that's extremely useful, but it's very limited. It only does position plus or minus, and you can zero it wherever you want. So it's not like a proper gyro that will give you whole positions. You know, that's beyond it. But it is still a useful thing to have. Machine-wise, it's got a reasonable envelope. I'll put up on screen how big the X, Y, and Z axis are, but it's not bad for a hobby-grade machine. It's pretty accurate, I have to say. I've been quite amazed at how accurate it is. You have to look back at some of my previous videos. There's a video way back where I built, can't find it, here we go. I built a tool setter, and I did some testing for accuracy and repeatability, and this machine turned out to be really quite good. In recent time I built a touch probe, and again I did some more testing, and I pretty much came up with the same conclusion. It's a pretty accurate machine. In general, I think I like it. Was it worth the money? I could probably sell it for pretty much what I paid for it. So yeah, it's in those terms, it's probably not a bad investment. What else can I say about it? I guess one of the things with this particular machine is I think it was designed as a plug and play machine for hobbyists, because you have your PC with which is over the side there with Mach 3 on it, and you literally plug Mach 3 into the side of the machine. The breakout board is in the control cabinet, which is at the back. So once you've got your PC with a DB25 connector on it, you can literally just load an XML file into the PC for the setup for this machine, which I got supplied with it, and it bursts into life. Really easy to use, very sensible, very good for people like myself who are learning. So having the onboard Mach 3 breakout board is quite good, but it also has limitations because there's no spindle tack, for instance. So the spindle on my machine, I put a magnet and a magnetic sensor up in the head here. So I get a once around. It sends a pulse to the computer once every revolution, which is extremely good for setting the spindle speed. You can go through an auto setup routine, and it will, within Mach 3, and it will run the spindle at all the speeds it's capable of doing, and set the PID loop within Mach 3, so that you when you type in Mach 3 to do 1500 RPM, it does 1500 RPM. That's really quite a useful bit of kit. But that doesn't come with it, so I had to add it myself. What else can I say? In bad terms, and I think I'm probably not the only person to have found this, the casting, or the machining on the casting for the Z-axis, the column at the back here, is not particularly good, and the head is not as rigid as it should be. The table I found is pretty good, but and it's all dovetails. There are no ball, no linear ways on this particular machine. The X5 I think had linear rails, but that was another £1,000 on top of the price, and I thought that's really a lot of money for what I thought would be a relatively small improvement. Probably was worth it. So what I've done is I had an old linear boreway, so I've added quite a beefy linear boreway to the side, and it's bolted to the casting top and bottom to make the column a bit more rigid. I designed that so that it doesn't actually, there's no more holes in the machine. It fits into is bolted to the lifting holes on the side of the frame, so it's not impinging at all on the rigidity and strength of the machine. I haven't had to drill a single hole in the machine to make it to fit it. And at the top, it fits into a couple of spare holes that are in the top of the column. So that has made the head a lot more rigid. I've got myself a list, so I'm slowly going through the list. Speed range. There's I think it's a 1,000 watt motor. It might be 750 or 1,000 watt 3-phase motor on the top that drives a spindle via a toothed belt, and which gives me a maximum speed. Well, we'll turn it on. We'll find out. 5,560, and at the other end I can get it to crawl. However, I wouldn't recommend you do this, but I'll put a load on it. There, you can't get it to torque out, but you wouldn't want to do it for long. However, let's turn the spindle off. Within Mach 3, I cannot get anywhere near that speed range. I can get the 5,500, 5,600 flat out, but I can't go accurately below 1,000 because the auto setup on the setting up the spindle speed in the PID loop doesn't work properly on the. I mean, I don't know whether it's a Mach 3 problem or whether it's this particular machine. If somebody knows where the details are stored within the setup config file, if you like, for Mach 3, I'd be interested to find that out, because I think I might be able to override the auto setup and put in my own values and get it so that it does work. Not entirely sure. It may be a function or problem with the computer, because the computer is spitting out pulse width modulated signal, and it may be the minimum pulse width that's causing the problem. So yeah, we'll see. I must apologise for my voice today. My tongue has gone a bit funny. It's dead. It's slightly dead on one side. I'm probably falling to pieces. That's what happens when you get to 58, nearly. Right. So the problem I think with the spindle speed is, and I can show you this, if you're using something along the lines of, dig out a tool here. I can't dig out a tool because I can't find it. Here we go. That's not what I was going to put up, but if you're using something like a slitting saw, you want that to run only at a few hundred RPM. That's possible with this, you know, a few hundred RPM. For me, this seems to be best between 1,000 and 3,000, let's say. However, if you want to start cutting something with, for instance, here we go. Excuse the cat; it's being difficult. This is a 4mm cutter. This one's high-speed steel, but I prefer to use carbide, like most people. The recommended speed for carbide, 4mm end mill, cutting mild steel, is between 5,000 and 11,000 RPM, depending on the material. So you can't get anywhere near the speed range out of this that you really would like to get the maximum sort of productivity out of it. However, it's a home machine. It's not really designed for spewing parts out every day, left, right, and centre. So I use the newfangled solutions from CNC Cookbook, G Wizard Speed and Feed Calculator, and on that I can't show you, unfortunately, because my laptop is packed in. But there's a tortoise and hare slider on it, which means that you can set it to maximum speed, which is for professional grade machines. You can derate it to any percentage down to 0. So I derate my speeds and feeds by 50%, and that seems to work quite well on this machine. So it's working at half the speed at best compared with a professional grade machine. So yeah, I think that's reasonable. It's because it's not rigid enough and it's not powerful enough and it doesn't have enough spindle speeds. So yeah, that's pretty much what I think of the old girl. So let's move on to stuff that I've done to it. Right, let me just mention Syil as a company. I've contacted them a couple of times, and I'm not the only one who's had no support whatsoever for this particular machine. They said, when I contacted them last, I was trying to get a circuit diagram for the breakout board, because sooner or later it's going to go wrong, and I thought, I was trained in electronics. If I can, I'll fix it, but it would be useful to have a circuit diagram. They don't have a circuit diagram, or they're not prepared to let me have one. They said, oh yeah, we'll get back to you when we found it. That was 3 years ago. So there's no support for this sort of machine. So it's down to us and the community to look after them. The other thing that I think is a little bit crappy is most people who have this sort of machine are going to put it on a bench just like this. They might go to the trouble of making a crappy wooden cabinet to put it in like this. and you're going to really, you want to slide it up against the wall so that it's out of the way, and in fact that's a good thing to do because you can secure it to the wall. You know, I've got a brick wall there that this bench is secured to. This bench is quite strong, it's not moving, but that means I can't get to the control cabinet. It's an absolute bloody nightmare to get into the control cabinet. So if you want to rewire something or have a little look at something, or in fact it took me ages to get it done, but I've actually put a spindle brake on this. So if I just run the spindle, when the variable frequency drive, and I think all VFDs have this, if you connect to a couple of pins a resistor and you have to work out what the value of that resistor might be, you can actually make it so that the excess power from when the spindle motor is spooling down goes into the brake resistor, which means that you can stop this spindle really quickly. So let's go up to, here we go, 5,600, and I'll turn the spindle off. That stops in 2 seconds, maybe 3. It's pretty quick. If I start that again and then hit the reverse switch, right, 5,600 clockwise, 5,600 anti-clockwise. That's pretty quick. That's a useful thing to do, and I think it's a useful thing to do from a safety point of view. If you hit the stop button, you want the bloody thing to stop. So normally that would take 5, 6, 7 seconds to slow down to 0. I've got a CNC router which is in bits at the moment. Oh, everything's in bits. That does 24,000 RPM, and it takes it 6 or so seconds to actually stop from that speed. So if you get yourself, if it's doing something it shouldn't do, or you've got you know, the work breaks free and you want to stop it, you want to stop it quickly. I haven't fitted a brake resistor on the CNC router. It's on the list of things to do. Let me quickly run through the mods that I've done to this machine. As I said, I put a magnet and a magnetic sensor in the top, so it gives me a one surround tack pulse that goes into Mach 3. Very useful. I've added the head support to make it a bit more rigid. I put coolant on it, so if I turn the coolant on, there's a pump in the bottom. Turn that off. There's a pump on the floor with a tank. The tank's not big enough, but it's like everything I do, it's a work in progress. Very useful to have. I added a brake resistor so that it stops the spindle as fast as possible. The best thing I've done is the power drawbar. Having the ability to stand on a switch, pop the tool out, put another one in, take your foot off the switch, perfect. And that's interlocked, so if the spindle's moving it won't allow you to pop the tool out. Right, the other thing I did is I made this control panel, and it's not finished. It was an experiment, to be perfectly honest. It works, and the basic controls I added work perfectly. However, I'm not really sure you need to do all of that. I think, in all honesty, if I was going to do something like this again and I was doing it on the cheap, I would just put a rugged keyboard and a touch screen and have a mouse. I still use a mouse, funnily enough, but the MPG is useful. Not essential, but it is quite useful for setting positions for 0, you know, your G54, that sort of thing. Worth it? Probably. Complicated? For sure. I'll show you inside. where am I going with this machine in the future? That's another good question. I'm glad you asked it. I'm building a new workshop. Those of you who follow the channel will know that I'm building a new workshop. I'm bogged down in building regulations, or code I think as the Americans would call it. I'm getting there though, slowly. I want to put this in a floor standing cabinet so that the PC will be built in, the control panel will be on an arm swung out the front of it, a much bigger coolant tray, and some method of clearing the chips out of the blasted thing. That's another pain in the butt. Is every time you use it, is cleaning the chip tray out. Also, rather than have the gas spring, I'm considering putting a weight the same as a head on a pulley and a rope. Well, steel hawser going over the pulley, so the head is positively weighted and self-supporting. So basically, if you were to take the ball screw off it, the head would float up. That's up to its maximum point. That's what I would really like to have. But I need to be able to get to the back. I also need, that will be where the electrical cabinet is, so that there's, yeah, you can see as much as I can. The control system, I really think Modbus is probably worth experimenting with. These switches and buttons are wired to another DB25 port on the computer, which has limitations. You've only got a few inputs and outputs, so you have to be quite creative with how you use those commands, and the little Arduinos in here effectively take control of the keyboard. So they say, I'm a keyboard now. When you change one of these switches, it says I'm a keyboard, changes something, and then it says, okay, I've done that, I'm now back to being an Arduino. Mach 3 doesn't respond to that particularly well. Some commands, if you look back at the videos when I made this, it's a bit haphazard as to how that works. I think the final considerations for this is that one of these machines is only half the story. You really need to be able to use it to its full extent, and I would thoroughly recommend anybody who buys a CNC mill of whatever flavour, learn a few of the G-code commands, so you can type in G-code commands and just get it to face stuff off and move to the position drill and that sort of stuff. That's it. Saves you reaching for the computer every time you want to do something simple. They're autonomous. Once you've got it programmed and running, you can leave it. I wouldn't recommend you leave it alone completely. I've gone as far as making a cup of tea, but that's about it. And I'm generally within earshot of the thing, because you'll soon hear if it's gone wrong. You can make some really quite complicated parts that are extremely difficult to make manually, if not some of them nigh on impossible. So there are some real advantages for having this sort of machine. Is it worth the money? Don't know. It's for me, it's a hobby grade machine. It's a lot of money for a hobby grade machine. I think the machines now are getting really quite expensive. Could you make one yourself as good? Yeah, for sure. Would you want to? Don't know. Anyway, and the final consideration I think for a machine like this is the machine is only half the story. You really need to be able to generate and program the cutting paths. So you've got to be able to have some sort of CAD CAM system. I use Fusion 360. I use Fusion 360 because it was free to start with. However, because I make these videos, it kind of, I think, compels me really to go for the paid version, which is about, I think it's about the £400 a year mark. Not really sure. It's been a few months since I paid my license. There are alternatives out there. There's FreeCAD, for instance, which is free. Don't know what it's like or the support on it. There's TurboCAD. There's a whole load of them, and Dassault Systems have entered the marketplace for a similar version to Fusion 360, which is cheaper. How long that will remain cheaper, I don't know. I think the two big players are Autodesk and SolidWorks. They're both pretty similar. Because I'm more European, I would lean toward Dassault Systems, but yeah, I don't really know if it's going to be any better. Because I'm now locked into Fusion, I'm going to stay with Fusion. So yeah. Anyway, thanks for watching. I know there's not been any machining in this video, but I thought having had a few conversations with people about this machine and CNCing in general, I thought it might be worth putting a quick video together to say what I like and dislike about the thing. And yeah, thanks for watching. Stay safe, and we'll see you on the next one. Hopefully we'll actually make something. Bye.